Hello viewers, in today's session we are going to discuss another important problem from differentiation, in which we are going to find out the derivative of this function, that is y is equal to f of x is equal to cot inverse 3x plus 4, using the concept of first principle, right? So viewers, we have already discussed these type of problems in our earlier videos. So here we'll see how we can find out the derivative of cot inverse 3x plus 4 using the definition, the limit definition of derivative. Right now, see, if we have a function, say y is equal to f of x, and the derivative of y with respect to x is given by dy over dx, and dy over dx is given by this limit, that is limit delta x tends to 0, and here we have delta y over delta x, and this is f of x plus delta x minus f of x divided by delta x, where delta x and delta y are the small increments in x and y, right, where x is our independent variable and y is our dependent variable. So now to get the derivative of y is equal to cot inverse 3x plus 4, let us first take cot inverse to the left hand side, so that we can write cot y is equal to 3x plus 4, right? Okay, now let us make a small increment in x, so that we can get a small increment corresponding to the value of y, right? So let us increase x by x plus delta x, so that y is increased by y plus delta y, right? So we have cot of y plus delta y, and here we have 3 of x plus delta x plus 4, right? So now this is equation 1 and this is equation 2. So let us subtract 1 from 2. So 2 minus 1 is given by cot. Here we have y plus delta y minus cot of y, and here we have 3x plus 3 times delta x plus 4, and then we subtract 3x plus 4, right? Now cot of y plus delta y can be written as cos of y plus delta y divided by sine of y plus delta y, and here cot y can be written as cos y over sine y, and here we have 3x plus 3 delta x plus 4, and here we have minus 3x minus 4. So 3x and 3x get cancelled, 4 and 4 get cancelled, so we are left with 3 delta x, and here we have used this definition of cot theta, that is cos theta over sine of theta, right? Okay, so now let us simplify this expression by taking the LCM, that is sine y plus delta y. Here we have sine y, and now we can cross multiply. So we have here sine y, and then we have cos of y plus delta y, and then minus we have cos of y, and then we have here sine of y plus delta y, and here we have 3 times delta x. So now let us see this expression. In the numerator, here we have sine y cos y plus delta y. Here we have cos y sine of y plus delta y. So here we can use this important result from trigonometry, that is sine a minus b is given by sine a, then we have cos of b minus cos of a, and then we have sine of b. So now if we take a as y and b as y plus delta y, then this expression in the numerator, it becomes sine a, then we have cos of b minus cos of a, then we have sine of b, and in the denominator we have sine of y plus delta y, and here we have sine of y, this is 3 delta x, right? So this is simply sine a minus b due to this result, and here we have sine y plus delta y, sine y, and here we have 3 delta x. Now see a minus b. Now a minus b is given by a y minus y minus delta y. So y and y get cancelled. So we have simply minus delta y. So here we have a minus b is equal to minus delta y. So this is sine of minus delta y over sine of y plus delta y, and here we have sine of y, and this is 3 delta x. So now here we can use an important identity from trigonometry, that is sine of minus theta is the minus sine theta. So sine of minus delta y is minus sine delta y, and here we have sine y plus delta y, and this is sine y, and this is 3 delta x, right? Okay, so now we have reached this important result. Now what we will do, we'll divide both sides by delta y, right? Because dy over dx is equal to limit delta x tends to 0 delta y over delta x. So let us divide both sides by delta y, and then we'll take the limit, that is delta x tends to 0. So dividing both sides by delta y, we have minus sine delta y over delta y. Here we have sine y plus delta y, and this is sine y, and here we have 3 delta x over delta y, right? Okay, now let us write this expression like this, that is minus sine delta y over delta y. So let us take this delta y in the denominator of sine delta y, and then here we have sine y plus delta y, and then we have sine of y, and here we have 3 times delta x over delta y. So delta x over delta y can be written as delta y over delta x, right? So there is no harm in writing delta x over delta y as delta y over delta x, right? Okay, now let us take a limit, that is delta x tends to 0, and remember delta x and delta y are small increments in x and y. So when we take delta x tends to 0, then delta y also tends to 0. So taking the limit here, delta y tends to 0, because here all the terms are in terms of y. So if we take the limit delta x tends to 0 on both sides, then here the limit delta x tends to 0 can be replaced by delta y tends to 0, and here we can now write limit delta x tends to 0, right? Okay, so now this limit is equal to 1 because sine theta over theta, limit theta tends to 0, is equal to 1. So this limit is equal to 1. So we have minus 1 in the numerator because limit delta y tends to 0, sine delta y over delta y is equal to 1. And here when we take the limit in the denominator, then this delta y goes to 0, so we have simply sine y, and here also we have a sine of y. And now in the right hand side we have 3, and we can take a limit delta x tends to 0, and this is delta y over delta x. Now this term is equal to the derivative, that is dy over dx. So now we have a minus 1 over sine square y, because sine y multiplied with sine y is sine square y, and here we have 3 over dy over dx, right? And y is given by cot inverse 3x plus 4. Now cross multiplying, we have dy over dx is equal to minus 3 times sine square y. Right now sine y is equal to 1 over cosec y, so we have minus 3 over cosec square y. Right now cosec square y can be replaced by this identity, that is 1 plus cot square y. So this is an important identity from trigonometry, that is cosec square theta is equal to 1 plus cot square theta. So we have minus 3 over 1 plus cot square y. Now cot y is equal to 3x plus 4. So we have minus 3 over 1 plus 3x plus 4, and here we have a square. Right, so this is minus 3 over 1 plus 9x square, a plus b whole square, then we have 16 4 square, and then 2ab, that is 2 times 3 6 times 4 24x. So this is minus 3 over 9x square plus 24x plus 17. Right, so dy over dx is equal to minus 3 divided by 9x square plus 24x plus 17, and the derivative, that is d by dx of cot inverse 3x plus 4 is given by this expression. Right, so this is how by making use of the concept of first principle we can find out the derivative of functions.